Hi, welcome back to our series on robotics. I am Jason Vasalio, and for this experiment, we will be controlling the angular displacement of a servo motor. Alright, so for objectives for this experiment, we have to control the angular displacement of the servo motor and to create a computer program user interface to send data controls to Arduino. And the materials that we will be using will be the following: the breadboard, servo motor, jumper wires, and an Uno board for our microcontroller. So the servo motor that we will be using for this experiment is the SG90. The SG90 micro servo motor, just like any other servo motor, has 3 wires. The orange one will be the pulse width modulation, and the red wire will be for the VCC, and the brown will be for the ground. Now, our board is again an Uno board, and for this experiment, we will be utilizing the D10 as well as the D11, as you can see here in this part, for our pulse width modulation. This is because you will be using 2 servo motors. So, for the schematic diagram, we have here, as you can see, 2 servos connected to pins 9 and 10 of our microcontroller, an Uno board, and their positive as well as the negative inputs are connected to the VCC and the ground respectively. So for the circuit assembly of our experiment, this will be our circuit assembly. As you can see here, we have the black connected to the ground of the breadboard, as well as the positive or the red wire connected to the positive side of the breadboard, and the yellow ones are for the pulse width modulation, which are connected to the pins 9 and 10. Now for the programming and demonstration, we will show you the first testing of the servo motor, and second, the actual experiment itself, as well as the programming and demonstration of all controls and the graphical user interface. Alright, so with that, let's proceed to our experiment. Alright, so now that we have finished the assembly, we can try and test this servo motor first. So to do that, let's create first the macros for the IO pins. That will be S1 as pin number 9 and S2 as pin number 10. As you can see here. Alright. So let's first declare the servo classes. Servo 1, Servo 2. Okay.
After that, hold on, we forgot to include the servo library. So let's first include that library, and after we can start the setup to servo 1 dot attach to S1. Alright, servo 2 attach to S2. And now for our loop, to test this out, we can type right, say 90, as well as for the servo 2 dot right to 90, and have a delay of 500 milliseconds. Let's set this to 180. As well as this to 0. Alright, so let's test this out. Let's first upload the program. Alright, so as you can see right here, the two servos are working properly. So the next thing that we can do is to create a program that will communicate with the serial monitor and turn the arm into the angle specified into this serial monitor. Alright. Alright, so now that we have completed the program, we can now try to test this out. So first I made this if function. If there's an available input from the serial monitor, it will first store that string into strcont, and cont will be the first character of that string, and angle will be the substring at position 1 onwards and converted to integer, and that will be our angle. So I created two switch cases. For the first one, case A, it will write at servo 1, and case B, it will write at servo 2, and that parameter, the switch case, will get the parameter cont, which will be the first character of our input. Now, so we can test this out first. Alright, so if we run the serial monitor and type A100, if you notice, the servo motor actually moved, but only a couple of angles, since it's already in this angle direction. So we can go ahead and try typing A180, and as you can see, the servo motor moved to the position of 180 degrees. So if we go ahead and type A0, the servo motor moved to the 0 degrees position. And if we try to move the servo 2, B100, the servo motor again moved, but only for a few degrees. So let's try a bigger or more degrees. Let's try B180. So as you can see, the servo motor moved. Let's try again B0. Again, the servo motor moved. If we try A90, and B90, we can control the both of the servo motors. Alright, so let's now try to create a program for this, a graphical user interface using the Visual Studio.
Right, so now that we have finished the programming for this graphical user interface, let me walk you through the program that I created. So first, we have here the design, the servo motor control. I patterned it over the Arduino color palette. And for this one, for the main one, we have here our, of course, we opened first the serial port for the communication, and I created two event arguments for the text box. For text box 1, which where our servo motor 1 will be, I created this if function that if enter is pressed, then it will send these the string that is in the text box to the serial port. But that string will have a, and the main text on the text box will just be appended to the A character. Similar with the text box 2, except the control parameter will be B. Alright, so let's start this program. So if we go ahead and type 0 to servo motor 1, as you can see, the servo motor moved. To servo motor 2, 0 also, we will see this servo motor move at 0-degree position. Now, if we enter 180 degrees, as you can see, the servo motor 1 moved to 180 degrees position, as well as if we move the servo motor 2 to 180 degrees position. So, we can go ahead and play around with this GUI, and it will, of course, output the desired degrees for the servo motor. So that will be it for our experiment. See you on the next one.